Thank you for visiting this poster entitled Changes in Exhaled Volatile Organic Compounds Following Iron Supplementation in Self-Reported Healthy Adults. It is my pleasure to review the findings of this study, which was done in close collaboration with the Functional Gut Clinic. Here we investigated the effects of iron supplementation on healthy adults. Iron deficiency anemia is a global problem affecting more than 1.2 billion people. Right here in the UK, it accounts for about 13% of gastroenterologists' referrals. Iron deficiency anemia can be treated with iron supplementation, either intravenously or orally. However, unabsorbed iron can cause gastrointestinal symptoms such as bloating. This is believed to be associated with intestinal microbiome changes induced by the iron treatment. These intestinal gases, including hydrogen and methane, can be absorbed by the intestinal tract and into the circulatory system. They can then be transported to the lungs and be exhaled. Breath tests can then detect these gases. Tests for detecting changes in the intestinal environment can be facilitated by using fermentable carbohydrates such as lactulose. Lactulose can be metabolized by intestinal bacteria rapidly, producing gases within 180 minutes. The time at which these gases are detected can be linked to regions in the gut where the bacterial metabolism is most active, thus providing insight on how iron treatment affects the regions along the gut. In this trial, 25 healthy volunteers provided breath samples collected in breath bags following lactulose ingestion. Samples were collected at 4 time points: at 0 minutes, 45 minutes, 90 minutes, and finally at 180 minutes post-lactulose ingestion. Over the following 28 days, volunteers ingested 200 mg ferrous sulfate tablets daily. At day 28, volunteers repeated the lactulose test, providing breath samples at the 4 time points. Breath bag samples were all sent to Ulster Medical Labs in Cambridge and analyzed using SIFT-MS technology. Targeted data were interrogated for statistical significance. It is shown that the exhaled compounds compositions in ambient samples were different from those in breath, and that the 2 ambient samples, one taken at the collection site in Manchester, which is called the room ambient, and the other at Ulstone Labs in Cambridge, called the lab ambient, are both different from each other. Among the compounds investigated, 7 showed significant changes after 28 days of iron supplementation. This was recorded at time 0, before the lactulose challenge. 3 compounds were further investigated: propanoic acid, acetic acid, and hydrogen sulfide. The first 2 compounds significantly increased after 28 days of iron supplementation. This indicates that iron supplementation was associated with microbiome changes that were most prominent in the colon. Also, both propanoic and acetic acids are short-chain fatty acids which are considered beneficial in gut health. Contrary to this, hydrogen sulfide significantly decreased over time following the lactulose challenge. Hydrogen sulfide is usually considered to be detrimental to gut health. Iron supplementation in this cohort appears to be beneficial. Further investigation on how this data relates to signs and symptoms of the volunteers will be done to understand the effect of iron on this population.